Hello everyone, I'm Siddharthan. Meta has launched its next generation of LLM called Llama 3, and a lot of people are discussing about the potential it has to compete with the industry standard models like GPT-4, Gemini Pro and other LLMs. So the best thing about the family of Llama models is that Facebook open sourced these models, so we can use these models for commercial use and other research purposes too. So in this video, let's understand how we can access this Llama 3 model and how we can build a text generation system with it in Google Collaboratory. So this is what we will be covering in today's video, and let's get started. So as I said, we will be using Hugging Face. So the first thing that you need here is you need to create an Hugging Face account if you don't have one. So again, Hugging Face kind of hosts a lot of models, and even you can access like Llama and Llama 2 model, and they have added this Llama 3 model, and this Llama 3 has like two variations. One is 8 billion and the other one is 80 billion. So the previous family of model was Llama 2, and that came like 7 billion, 13 billion and 70 billion. So this has like 8 billion and 80 billion, and within this 8 billion and 80 billion there are also two other variation. One is just this base model and the other one is instruct model. So I'll explain you about all these things. So for getting started, right, so just sign up for Hugging Face if you don't have an account. So once you do that, right, so you can go to this Hugging Face page in Google. So sign up, and in this search bar, even before signing up, you can just go to this Llama 3. So you will see this in the initial place. If not, you can just go ahead and search Llama 3, and you will see this. So you're seeing this 8B, right? So you will also see this 80B instruct and 8B instruct and so on. Maybe let's just go with the base model first, and here you will see this. So you need to agree to share your contact information to access this model. So there are like some terms and conditions you need to agree, and it's like completely free. It's not like we need to pay anything or something like that. Just scroll below, you will see this option to log in or sign up. So once you log in or sign up, right, so there will be this accept terms and conditions thing. So once you do that, it would say that your request is being reviewed, and maybe after an hour or couple hours you will get this access. So if you refresh this page, you will see that you will have access to this model. So you will also get a mail in which you have like signed up in your Hugging Face account. So this is how it would look like once you have the access. So you will see that gated model, you have been granted access to this model. So once you have this, you can go ahead and start working on it. So this is how this works. And as this is a gated model, we need to provide the access token from our Hugging Face account. So we have this collab environment, right? So here we are going to load the model from Hugging Face. So here we need to get this access token, put it in this collab environment so that we can authenticate that this is the account through which I'm trying to access this model, and I have like reviewed all this terms and conditions and so on. So that's about it. Okay, so now let's understand how we can work with this. So the first thing is we need to install a bunch of libraries, and we need to save this HF token or this Hugging Face access token. So let's maybe discuss like how we can do that first. And you need to connect to a GPU environment. So go to this runtime, go to this change runtime type, and select T4 GPU. Okay, so if you have Google Colab Plus or Colab Pro, right, so you will kind of get access to more powerful GPUs, but I mean this is not required. You can choose T4 GPU, and the size of this 8 billion model is about 15-16 gigabytes. Even that you won't be able to do this in Collab, because Collab just offers you 15 GB of GPU RAM. So what we are going to do is do a process called as quantization. So I'll explain you about all those things. So for that we of course need this GPU setup. So that's why you need to kind of have this T4 GPU setup, and you can give this connect this thing. Then go to your files section. So you're seeing this files, right? So once you're connected it, we are going to create two files. One is requirements.txt to mention all the libraries that we need, and the other one is config.json. So I'll just right click here, and I'll see this option called as new file. So here I can say requirements.txt. So in this untitled, I'm going to say requirements.txt, and here I'll enter it, and this will save this file. Now double click this, and this file will be opened here. So here we can install the required libraries. So we'll be needing three libraries. The first library is called as accelerate. So I'll say accelerate pypi in order to get the package index. So again, this is used to do the quantization. So quantization is nothing but we would reduce the precision of the model so that we can, let's say the 15 GB model won't be 15 GB anymore. So it will be around 6 GB. So again, it's a trade-off between the accuracy and the performance that we would get. But again, we can't load a 15 GB model if we don't have that much computation power. So that's about it. Okay, so let's install this accelerate. And next we need this bits and bytes configuration. So again, come to Google, search bits and bytes. So all the latest version should be good. So in this bits and bytes, download this. Again, if you have a laptop or a PC with, let's say, a larger GPU, you can do this in your local Jupyter notebook too. But again, if most of us may not have this, so that's why I'm doing this on Collab. Or if you are working in an organization and you can use their AWS SageMaker notebooks, then you should be good, because that gives you offer to larger machines. So that's good too. And then we are going to check transformers. Transformers is nothing but the Hugging Face library. So that's called as the transformers one. So you can see this. So here I'll copy this transformer 4.40 and paste it here. Okay, so we need to install these three libraries. If you want any other libraries, or if you're working on something else, you can install that too. So I'll save this, and now here I'm going to save exclamatory marks to run this as a command and say pip install r requirements.txt. Okay, so this will install all the libraries present in this requirements file. So the next step is creating a config.json file and putting your access token there. So there are like a few ways to do this. One is you can use a .env file so that you can save the access token in the environment variable, or the other step is you can create a JSON file and load it and pass that HF token. So here I'll create another file and I'll call this as config.json. Okay, so config.json. So you should kind of have the data in the format of a dictionary. So double click this. So now this is empty, and here I'm going to create a key value pair and I'll call this HF underscore token. So this would be my key for my JSON file. So I'll come to this Hugging Face account, go to, so this on this right side you're seeing this, right? So this is your profile thing. So click this and go to your settings, and in this settings we would have this access tokens. So in this access token you can copy your access token and paste it there, right? So here I've already created like a access token. Maybe I can delete it and I'll show it to you, or you can do this. So I'll create a new one, and maybe after I posted this video I can delete this. So make sure you're using your access token. So the token that I'm going to show in this video won't work because I'll delete this. So again, these are like pretty confidential information, so you shouldn't share your tokens publicly, and that's what they have mentioned as well. But just for this tutorial purpose, I'll just show you. So go to this access token in your settings tab, and in this give new token, and let's name this as Llama 3 getting started. So this name is not like important. You can give any name and you can like kind of write it, or like you can basically give different permissions. So for this particular thing, read permission is enough, and say generate a token. So you can show this, or you can copy this from here. So it will say copied. Now come back to your HF token, and then in this again put double quotes and put your access token here. Okay, so I'll save this and close this config.json. So now what we are going to do is save this config.json to a variable. So maybe that we can load later. Now we can import all the libraries. So installing of this libraries may take some time, so we need to wait for that. So here it has installed all the libraries. Now let's go ahead and do this code of importing it, configuring the transformers library, the Hugging Face library, and loading the model quantization. So we can start with like all those things. So first I'll maybe say this part is installing the dependencies. Okay, so next step is we are installing the dependencies, and now we are going to import it. So here I'll say import JSON. So I'm importing JSON to read this JSON file and later pass that HF token to this transformers library, and then I'll import this torch. So torch also we need in order for this setting up the data type for this quantization. And then from transformers import. So here I'm going to import like multiple things. So I'll put a parenthesis here just like a tuple and say that again this is like a better way to import if you have, let's say, 5 or 6 methods or classes that you need to import. So you can just put a parenthesis and within that you can import it. So I'll say first thing that we need is a auto tokenizer. From this we would kind of import the tokenizer of the Llama 3 model, and then we would have this auto model for casual ML. So all this other model as well. So casual okay, sorry, casual LM, and basically the language model and bits and bytes configuration. So B should be in caps. We have bits and bytes. So pay close attention to the uppercase and the lower case letters. So bits and bytes config, and here we will pass the quantization configuration, and finally pipeline. So we would create a text generation pipeline. So let's run this. So these are the things that we need. So we have auto tokenizer, from which we will load the tokenizer of the Llama 3 model, and auto model for casual LM. So okay, I think I made a mistake here. Casual auto model for casual. Okay, so not input name. Let me check this quickly. Let me check this. Sorry, so this should be causal, should not be casual. So rename this to causal. Okay, so let's run this again. And sorry, there is a typo. So this will import all the required methods or the classes that we need. So the next thing is we are going to configure the transformer library. So I'll create another text cell, and here I'll say HF. So the HF basically means Hugging Face. So Hugging Face account configuration. Okay, so here let's load this config data. So I'm creating a variable called as config data, and within this I'm going to say json.load open config.json. So here what this does is this json.load will open this config.json file and save this in a dictionary, convert this load will convert this json to a dictionary, store this in this variable, and then you can store this token using this variable hf token is equal to config data, and in this you can say hf underscore token. Okay, so let's run this. So this will read this file and save the token. So I can copy and paste it here, and then can show it to you. So you can, I mean, you can directly copy and pass this to the variable, but that is like not recommended at all, because you shouldn't post any API keys or access tokens directly in your code, so that, because if you're sharing your code then others could see it, right? So for that purpose you shouldn't do it, but this is just for your learning purpose. I'm just showing this to you, but this is not recommended. Okay, so we have loaded the configuration token to this variable called hf token, and next we are going to give the name of the model. So I'll say model name, or you can also use the variable model id, so that is also widely used, and we need to copy the name. So come back to your Hugging Face and search for Meta Llama 3 8 billion. This is the name, so you can copy this and paste it here. So meta hyphen llama meta llama 3 8 billion. So run this. So the next step is we are going to create the configuration for our quantization. So here I'll create a text and can call this quantization configuration. And as I said, the purpose of this quantization is the LLMs that we are working on. It can be a GPT-4 or it can be a Llama 2 or Llama 3 or any other LLMs. Like these models are pretty big. So what we do is we do a process called as quantization, and this will shrink the model. So how this does is this will change the precision of the weights. So we know that all the models, the deep learning or any models would have parameters or this weights, right? So this would be in a higher precision, like 32 bits. So here we can we have this ability to use, instead of 32 bits, you can use like 16-bit or even like 4-bit weights and parameters. So that's what we call as quantization, and we kind of do this. And of course there's going to be a trade-off, because we are reducing the size, but the loss in that performance or the accuracy won't be that big. So this is just to kind of do this analysis or working with LLM even if we don't have like that large of a GPU. So here if you see this, right, so the GPU RAM is 15 GB. When you load your LLM and just pass one prediction, your GPU is going to fill and your collab session is going to terminate. So we don't want that to happen, so we will quantize this and load this to the GPU. And when you load it, right, so that is going to take only like 5.5 or 6 gigabytes of GPU RAM. So that's the reason we are kind of doing this. So for this, we are going to create a variable called as bnb f underscore config, and within this I'm going to say bits and bytes, the one that we have imported, put a parenthesis and say load in 4-bit, like all the ones that are mentioned here. So load in 4-bit. So here I'm going to say true, and the next is bnb 4-bit use double quant. Use double quant is equal to true. So this double quant is equal to true is like, this is nothing but, so we are telling this bits and bytes that I want to quantize this model, but I don't want to lose a lot of information, so that my model is performing well. So this double quantization helps us to preserve the performance of the model, or like it doesn't allow the model to lose a lot of information or its ability to perform by reducing this precision. So that's what like this parameter is used for. And then I have this parameter called bnb 4-bit quant type. So this is like one of the types of doing this quantization. So quant type is equal to, that is this type called as nf4. So this is what we are going to use. And then we have this bnb 4-bit compute d type. So we need to pass the d type. So for passing this d type, we'll be using this torch. So we should that's right, actually we have imported this. So here I can say torch dot bf float 16. So we can use this 14-bit floating point. So I'll run this. So now we have to pass this bnb config, this bits and bytes configuration for quantization while we load the model. So that's the purpose for this. So once this is done, the next step is loading the tokenizer and the model. So here let's say loading the tokenizer and the LLM or the model, you can call it whatever you want. So here I'll create a variable called as tokenizer. So I hope you know what is a tokenizer. So this tokenizers are used in NLP cases. It's just to convert the raw input string to a format that the model needs. So all these models, right, so it can be any LLMs that you're working on. So each of these models would have like a separate LLM for that. And for this LLM, this Llama 3, we have to use the tokenizer that is used for this Llama 3. So you can go to this tokenizer and we have this auto tokenizer, right? So you can give that here. So I can copy this and paste it here. And within this auto tokenizer, you can say auto tokenizer dot from pre-train. So this is a pre-trained model, right? The Llama 3 one. So say pre-train, and you have to give the model name. Again, if you want to use a Llama 2 model, you just have to find that name. So for Llama 2, you can just say Llama 2, and Llama 2 has like a chat variation too. So chat HF, so this performs well in chat scenarios. So you can try this model also. You just have to change this model name to that one. So the other things can stay the same. So I'll copy this model name, and the next parameter that you have to pass is your HF token. Okay, so here I'll say token is equal to HF token, which is what we have loaded, and I'm going to say tokenizer dot pad token is equal to tokenizer dot EOS token. So let's run this. Okay, so you can see the tokenizer size 9.8 MB. This has been loaded, and it says like special tokens have been added in the vocabulary and so on. So this is how you can load this tokenizer, or like any pre-trained tokenizer, you can just give that name, and I mean all the models doesn't require this HF token. So Llama 3 models require your access tokens. There are some models for which you actually don't need these tokens. For that, you don't have to include this tokens. And then we have this tokenizers dot pad token, right? So this is like an interesting thing. So pad token is nothing but the padding tokens, and EOS token means end of sequence tokens. So it's like when you pass a set of sentences, or like let's say a batch of input, right? So all these sentences of the data points that are being processed by the tokenizers should have the same length. And what would happen if you don't pass this end of sequence, right? So the, let's say there is like a particular sequence is short, the input text is short. In that cases, we would like add extra spaces to it, and then we would pass this to the tokenizer. But when we add this EOS, end of sequence token, it would add a marker to say to the tokenizer that this is the end of the sentence, just process until this point. So that this is like a better approach to do this. So we are setting this pad token to this end of sequence token. And the next step is similarly from this, we have imported this model from this tokenizer from this auto tokenizer, right? So similarly, we are going to load this LLM from this auto model for causal LM. So for that, I can say model is equal to auto model for causal LM, and within this parenthesis, okay, I have to say from pre-train. So here we have to pass some parameters. The first parameter is the model name, so the Meta Llama 3 model, and then device map. So this is a very important thing. So here this tells you whether to load the model in your CPU or GPU. So here I'll say device map is equal to auto. This means if there is a GPU, it will automatically kind of allocate that space in the GPU, and it will load the model in this GPU. If not, you can also say CUDA, or you can say that I want to load this in the CPU, right? So that will basically load your model in your RAM. And again, so this is kind of crucial, because when you are working with a larger machine, so let's say that you're working with a SageMaker notebook instance that has like 8 GPUs. So you would probably work with like a G548X large machine. So that's like a pretty large machine that has like 192 gigabytes of GPU RAM. So there again, as I said, it has like 8 GPU. So let's say this 80 billion model would be somewhere around 200, be 150 to 200 GB. So I think that's the size of the model that it would be. And this model, right, would be loaded in all these GPUs. It would kind of be distributed in all these GPUs. So when you say this device map is equal to auto, it will kind of automatically allocate the model to the GPU or the RAM that is available. Or you can also configure this, or like custom load this model, so that's possible too. So here I'll say device map is equal to auto, so that this will like load the model in my GPU RAM only. So I'll tell this, and the next thing is I'm going to pass this quantization config. So if you don't do this quantization config, it will load in this default precision. And again, if the model is 15 GB, your GPU RAM will be filled with 15 GB. So again, we don't want that to happen because of our lesser GPU size. So pass this BNB config which we have created here, and then you have to pass your token too. So my token is hf underscore token. Now let's run this. So this will download the model. So here you will see like the size of the model. So we totally have like 4 shards for this model, and the first shard is like 4.98 GB. So all these 4 shards will be downloaded first. So here if you see this, right, so what is happening is like it's downloading this shards to this disk. So you have 2 gigabytes of disk. And again, we are just working with the 8 billion model. If it's 80 billion the model, of course it's going to be more than 150 gigabytes. So even your disk will kind of fill. So it's not like ideal to work with it in Google Colab. So of course you need a larger machine. So it's as it's downloading, you will see this increase in this disk space. So once the model has downloaded, what would happen next is this will load this model into the GPU. So that process will happen next, and you will see how this GPU RAM is filling once all this safe tensors, this shards kind of completed loading. So the first shard is 4.98 GB and the next shard is like 5 GB. So similarly we have like 2 more shards, and as you can see it's like downloading in a very good pace. And if you're working in a Jupyter notebook, in a local Jupyter notebook, you won't be having like this fast of a speed. So I can I mean this is like pretty high speed, right? So it's happening in collab so that we are kind of able to load this. But again, if you're working in your local, so that might take a lot of time. So the other option is Meta should have given this repository access, so you can also download the model from there and then you can load it too. So even that is possible, so you can try that out too. So let's wait for this download to complete and we can check how this model is loading. In the meantime, we can do the other things required. So here I'm going to create a pipeline. Right? So for that only I've imported this pipeline thing. So I'm going to create a text generated pipeline. So here I'll say text generator is equal to pipeline, which I've imported from transformers library. And within this, let's say the first parameter is what's the kind of pipeline that you want. So there are like different pipelines that are available in transformers. So again, a question answering pipeline or a text classification pipeline, but we are interested in text generator, so we are kind of using that. Okay, so uh, you can go to Google and search transformers pipeline, and there you can find like the different pipelines available, and or you can use like different pipelines, I mean of your choice. So these are like text classification, it would like give an output, so you can expand this and see like, so we have audio classification, automatic speech recognition. So all these pipelines are there, but we have focused on text generator. And in the meantime, you can see the shards have downloaded and now it's loading the checkpoint shards. So if you open this, your GPU will start filling. So this is loading the downloaded model to the GPU RAM. So you can see this. So as you can see, the total downloaded size is like 4.9 plus 5 plus this is also almost space. This is like 15 and almost more than 16 gigabytes. But once the model is downloaded, it's around this space. I think this will slightly increase, right? So it has taken like 5.6 gigabytes. So this is what we have done with quantization. So right, and then now we can create this pipeline. So text generator and say model is equal to model. This is the parameter and pass the model, and you can also pass the tokenizer. Tokenizer is equal to tokenizer. So this we have already kind of loaded these things, and we have to pass this to the respective parameters of pipeline, and then max new token. So this is like kind of like the length of the output that you are expecting. So default, I think it would just return 20 tokens, but again, if you want a larger response, you can use like a larger number. You can also use like 256 or like 512. So that's completely fine as well. So let's run this. So this is our pipeline. Now we will use this pipeline. Okay, unknown or text generator. Sorry, this should be text generation. Let's run this again. Okay, so this has created my text generation pipeline. Now I'm going to create a function called as get response, right? And say prompt. So this is the prompt that the user will be sending. And let's say sequence is equal to text generator, which is the name of the pipeline that we have just now created. and within that you have to pass the prompt and then say gen text. Generated text is equal to sequences of 0 generated text. So I'm doing this because this is how the response from the model will look like. Return gen text. So when you pass this prompt to the text generated pipeline, right, which has the LLM, the Llama 3 model, it would return a dictionary. And that dictionary we have to look at, which is basically, I would say the sequence. Sorry, not a dictionary, but a list. So within this list, we are taking the first element and finding like the generated text. So this would be the response. Maybe I can show you how this output looks like and later explain you this function. So here, let's say the prompt that the user is sending is what is machine learning. Let's say this is the question and the model should answer this. And I'll say text generator and pass this prompt. Oh, sorry, I have to run this. Let's store this in a variable called as response. And I'll copy this too. So let's see the output. So this may take a few seconds. And the other thing is like this is the base model, so this is not optimized for chat yet. So if you ask a question, right, so it's likely that it may not give you a very accurate response. Here we are seeing that what is machine learning. Machine learning is a branch of artificial intelligence that deals with development of algorithms and so on. So here we are seeing, right, and sometimes it's possible that you may not get this answer in a really good way, because as I said, this is not fine-tuned for chat. We also have this other variation called as instruct, as I told you. So that is like instruct is basically fine-tuned to understand instructions better. So that's again better if you're working with RAG task. Like let's say you have a document or you have a context and you want your model to answer from that context. So in those cases, instruct would probably work better than a chat model. So again, the point that I'm trying to make here is like don't expect like very accurate answers, because this is not a chat based model but a text generation model. But again, for Llama 2 we have a chat based model, as we have seen, so you can use that if your application kind of is like completely like a chat based one. But yeah, this output seems to be fine. But okay, so this is how this would look like. So keep all these things in mind. So how this output is looking like is I have get a list, right, and this is what I'm doing. So in this sequence, in this response that I've gotten, I need to look at the first element. The first element is nothing but this, and this is a dictionary. So from this dictionary I want to get the generated text key alone. So when I pass this, so take the first element, get the value of this key which is generated text, this would output this what is machine learning thing. Okay, so that's the reason that we have created this function. So I'll move this prompt down and I'll delete this one. Now we can basically use this get response and pass this prompt and so on. So let's run this prompt and call this function. So here maybe I'll create a variable called as llama response, or I can call this as llama 3 response is equal to get response, and within that pass your prompt. Okay, and now you can print your llama 3 response. This will just give you the output that the model has generated. So you can just run this, or you can also print llama 3. Right, so you can kind of get this. So if you don't want this question that the user has printed, right, so what you can do is paste this and say you can just slice it. So length of my prompt, and so this would remove that question, the prompt that we have sent, and this would display this. So this is how you can use the llama 3 model, load it from Hugging Face, and you can get a response. So how you can deploy this is, right, so that is a package called as Gradio, so that lets you deploy this as a API. So you just have to pass this function to this Gradio. You can maybe look into some reference, or later I'll make a video on that too. So you can get a API endpoint for that, maybe build a Streamlit app, and once the user has asked, some prompt, right, you can pass that to the Streamlit app and get this response and display it there. But this is how you can basically access your Llama 3 model and work on it. So I hope everyone is clear until this point, and I'll just give you a quick recap of what we have done, and so that like it's really clear for you. So the first thing to do is make sure that you're signing up to Hugging Face and accept to the terms and conditions, and once you will receive a mail, or you can see this here, that you're you have been granted access to the gated model. So once you have this access, go to your account as I've shown you, get the access token, put it in a config.json file, and also give all this requirements.txt with all the proper version numbers and so on. And finally you can install the libraries and then import the required libraries, configure the HF account with the tokens, mention the model name. We have to do this quantization, which is like a critical part in this case, which is reducing the precision of the model so that we can work with a smaller model size without losing any performance or the efficiency of the model. Then you have to load the tokenizer from auto tokenizer, and load the LLM with the model name, device map to say that loaded to GPU, and so on. And finally you can create pipeline, text generation pipeline, and get a response out of this. Pass a prompt and you can get a response from this. So I hope this is useful, so please try this out. So this is like not complex at all, so you can try this with your application. Let's say you are working on some chat applications or like text generation applications, you can definitely try this model out. And the important reason being, this is like a open source model as good as GPT-4 or Gemini Pro. If you're going with the GPT-4, right, so there is always going to be API cost that's going to be coming along with it. So but if you have a larger machine, you can host your Llama 3 model here and you can work on it. So that's it from my side, and I hope that this is useful to you. So subscribe to my channel for more videos on this AI, ML, Gen AI related stuff, and I'll see you in the next upload. Thanks for watching.